Hello everyone, welcome to another SP class. So today we are going to discuss sorting techniques. So in the previous class we have discussed about the assembler. So we have discussed the databases in the assembler. After that you have the flowcharts, the pass 1 and pass 2 flowcharts. So both pass 1 and pass 2 are important, very important. Pass 1 overview will be asked for 5 marks and overview pass 2 also will be asked for 5 marks. Detailed pass 1 and pass 2 are 10 mark questions. So if pass 1 overview is asked, detailed pass 2 will be asked. So that's how the pattern is. So of these four algorithms, definitely two will be asked for 15 marks. So don't miss it. So how do you study it is you can write it as an algorithm like in points. Okay, and then convert the algorithm into flowcharts. That will be a little bit easier. Okay, so do that, study the overview and also the detailed pass 1 and pass 2. Any doubts you can always write back to me, so I will clarify. Next, let us start the sorting techniques. Yes, so we have various sorting techniques: interchange sort, shell sort, radix exchange sort, and address calculation sort. So let us start with the interchange sort. So what are we doing in this class is we will be taking a list of a list actually, and we will be sorting it using various techniques. So that's what we are going to do. Let us start with the interchange sort. Yes, so what I have here, I have 12 numbers. So these are the numbers 1 to 12. So the numbers are going to be 19, 13, 5, 27, 1, 26, and so on. So this is the list I have taken. I am supposed to sort it using interchange sort. Interchange sort here is like your bubble sort. It is very simple. We're just going to compare the position number 1 and the position number 2, then the position number 2 and 3, and so on. So we are going to keep comparing the consecutive positions, right? So let us start. So here the first position is 19, second position is 13. So I have to make a comparison between 19 and 13. So 19 and 13 I compare, whichever is the smaller number I write that in the beginning and then followed by the bigger number, right? So again I repeat, we had two numbers. First position is going to be number 19, second position is going to be number 13. I have to compare position number 1 and position number 2. So 19 compared with 13, 13 is smaller, 19 is bigger. So next thing is we have to compare position number 2 and position number 3. Position number 2 has 19 and position number 3 has 5. So we have to compare 19 and 5. Okay, so 19 is position number 2, 5 is position number 3. 19 and 5, 5 is a smaller number, so 5 and then comes 19. Then position number 3 and 4. So 3 is 19, position number 4 is nothing but 27. 19 and 27 I have to compare. 19 is a smaller number, 27 is a bigger number. Now 27 and 1. 1, 27. 27 and 26. 26, 27. So 27 and 31. 27 and 31. There is no change. 16 and 31. Yes, 16 is a smaller number. 31 is a bigger number. 31 and 2. 2 and then 31. 31 and 9. So it is going to be 9 and then it is going to be 31. 31 and 11. 11 and 31. 31 and 21. 21 and 31. So if you observe this, the first iteration is over. We have compared all the consecutive numbers starting from 1 to 12. This is known as your first iteration. At the end of your first iteration, you will have the largest number. So this is going to be the largest of all number. Similarly, second iteration will give you the second largest, third iteration will give you the third largest, and so on. So let me do one more iteration. Yes, so 13 and 5, so it's going to be 5, 13, 13 and 19, it is 13 and 19, 19 and 1, it is 1, 19, 19 and 26, it is 19 and 26, 26 and 27, it is 26, 27, 16 and 27, so 16, 27, 27 and 2, 2, 27, hope you understand. 27 and 9, 9, 27, 27 and 11, 11, 27. So 27 and 21, 21 and 27. 27 and 31, it is 27 and 31. Yes, we have done with the second iteration. So what did we get in the second iteration? We have found out the second largest number. So we are sorting the list. You can see this list is being sorted from the last number. Okay, sorting is happening from the last number. After the 12th iteration, you would have sorted the whole list. Okay, so let me show you how it looks. So this is how your list is going to look after sorting. So first iteration gave you the first largest number, then the second largest, third largest, and so on. So you keep sorting it. So this is here. Yes, yes, this is going to be, say, the sixth largest, fifth largest, fourth largest, third largest, second largest, and first largest. So all the largest numbers are here. So you have to write the whole iteration. So you know that it is very simple, but marks will be given only if you write the steps. Okay, so don't simply think it is easy, so I will only write the first step and then write the sorted order. It doesn't work out like that. So you have to write all the steps. Whatever I have showed you, you should be writing all the given steps, right? So one more thing is, whenever sorting technique, definitely one question will be asked. It is very simple, so that is why I thought of including it to my list of important questions. It's very simple. Usually there will be a number given and you will be asked to sort. Okay, a number set of numbers will be given, and this is the usual list. Same list is what I have taken, which is in your textbook also. So in the question papers also, mostly if the numbers are given and asked, this will be the list. So if you go through these enough, you can do it on your own. Okay, but mostly how it is asked is, it is only asked explain interchange sort. It is like asked like a theory question. So you can take your own list and sort it. That's it. You just have to say what do you mean by interchange sort. Just try to write it in words and then give one example, right? So both the ways, this example is going to be helpful for you, right? So this is interchange sort. Any doubt? We are just comparing the consecutive locations and sorting the given list. Shall we move on to the next sort? The next is your shell sort. Shell sort is a little complicated sort, but if you understand and see what is the method, it will be very easy. Usually the second step here is forgotten usually. So you have to remember that there will be two steps in every time you sort it. There will be two steps. I'll tell you what those two steps which you should remember are. So let us start now. So whatever is the given list, shell sort uses this method wherein you are going to take the number of elements divided by 2 and that forms your D. Okay, so it is similar to your binary where you divide the number of elements into two different sets. Okay, something like similar to that. It's not the same, it is little similar to that. So what I have done in the first step, I had 12 elements. I have made taken 6 elements. I'm dividing the 12 elements into 6 groups, 6 elements groups. Okay, so 12 elements, I'm going to divide it into the first group, which is in blue, the second group is in green color, right? That's how I have divided. Now what I'm supposed to do is I have to compare the ones, the twos, the threes. Okay, so let me still, since it is the first step, let me show you in a little detailed way so that the other things will be easier. As we go, it will be easier for you. Right, I'm going to take the elements like this. I had 12 elements, so I had 1 to 12, right? So I'm going to take them as 6 elements. So what I am doing is this. So I had 12 elements, so I'm going to divide them into two groups with 6 elements. So what I'm supposed to do, I will compare 1 and 1. Okay, I will compare 2 and 2, 3 and 3, 4 and 4, and so on. Whichever is a smaller number, that comes to the top and the bigger number goes to the bottom list. So that is what we are going to do here, right? So we have divided into 6. So let me just take you through. See, for example, this iteration I'm going to divide 12 by 2, so you got 6. The next iteration I'll be dividing 6 by 2, it will be 3. So how many threes you will get? 3, 3, 3, and 3. Okay, so that time you have to compare all the ones together, all the twos together, and all the threes together, and so on. So the iteration goes on like that. You understand? So that is going to be the idea behind the method. As we go, you will understand. Right, so let me start with now. I have to compare the first 1 and 1. So 19 compared to what? 31. 19 is compared with 31. So I'm going to write 19 here, right? And 31, no change. So that is 19 is smaller, so it always stays in the top list. Now I'm comparing 13 and 16. Here also there is no change. 13 is here, 16 is here only. Then I'm comparing 5 and 2. So now there is a change. 5 and 2. 5 is bigger than 2. So 2 will come here. 5 will go here. right? Then comes 27 and 9. So 27 and 9 here, 9 is going to be on top and 27 is going to be here. 9 and 27. 1 and 11. So 1 is going to be here only because it is a smaller number. 11 remains here. There is no change. No interchange is happening here. So the last number here is going to be 26 and 21. So 26 and 21 interchange is required. 21 goes here and 26 goes here. You understand? This is going to be our sorted list after the first iteration. So sorted list after the first iteration. So this is what we have done here. So ones and compare ones and ones, twos and twos, threes and threes. Right? In this case, there is a 1 here and there is a 1 here. It is already compared. Okay. In other cases, there will be more than 1. Okay, ones will be 3 ones, 4 ones will be there. That there we have to go to the second step also. Step 2 also is required. So here this iteration had only one step. You just compared 1 and 1, 2 and 2, 3 and 3. That's it. First this iteration is over, right? So let me go to the next iteration. So again I'm going to divide these numbers into two groups. So here what have I done is I have divided the list into three groups, three in one group, right? So this is the first group. So it is going to be, again, let me number and show you just that you know. So 1, 2, 3. This is the first list. 1, 2, 3. Second list. 1, 2, 3. Third list. 1, 2, 3. Fourth list. Yeah. So what is that we did last time? We compared ones and ones. Here also we are going to do the same thing. 1, 1, 1 and 1. So we are going to compare ones, right? So you can do it in however way you wanted it to, right? So I will simply compare two and then tell you what we can do. Okay, so what is the method I'm using? We just have to compare ones. All the ones has to be compared and sorted. All the twos has to be compared and sorted. All the three has to be compared and sorted. So let's see how it is going to be done, right? So 1 and 1 now, 19 and 9, right? So it's going to be 9 and then you have 19. Let us finish with this. 13 and 1. So 1 is here and 13 is going to be here. 2 and 21, no change. 2 and 21 is going to be here, right? So 31 and 27. So 27, 31, yes. 16 and 11, 11 here, 16 here. 5 and 26, 5 here, 26 here. Okay, we have done. We have compared 1 and 1. Which ones we compared? We compared 19 and 9. But have we compared 19, 9 with 31 and 27? No. We have compared this separately and this separately. So this is going to be the first step of us, right? But this iteration is not over yet. Okay, so we have to go to the second step where I will compare 9, 19, 9, 31 and 27. I'll have to compare. Just for your understanding, I will just mark them. Let us see what are the ones we are going to compare. I just mark and show you, right? So these are the numbers I'm going to compare, right? The second step is going to be compare all the ones. So we have not done that completely. We only done it partially. So we are going to completely do it. How am I going to do that? 19, 9, 19, 27, 31 is there. So it is already sorted. So there is no issue. So when I compare all the ones, I see that it is already in the sorted order. All the ones are compared and then only the smallest one is coming to the top of the list and the others follow. So that is there already taken care in this particular thing, right? So it is going to be 19, 27 and 31. Now let us do the same thing to the other cells also. Okay, so we're going to do the same thing to the other cells. Now once over, now I have to now work with what? I'll have to work with twos, right? So let me see what I'm doing with the twos, right? So this is going to be 2. Yeah, this is 1, 2 and goes on, right? This is the second element, right? 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, right? So all the twos are here. So though we compared 13 and 1 and all, but still we have not compared everything together. So when you have a take a look at all the second elements. So what you see here, 1, 13, 11, 16, it is not in the sorted order. So I'm going to do a sorting here. So what happens? 13, 11 and then 13. So I'm comparing everything. All the twos has to be compared as per our step. Okay, as per our logic, all the 2's has to be compared. Yes, that's what we did. So let us go to the 3's. So all the 3's I'm going to compare. So how am I going to compare all the 3's? Let me see. Let me give other color, since you hope you have understood what I'm saying. So I don't think there is a problem. So all the 3's, right? So you can see ones are in white color, 2's are in blue color, and 3's are in yellow color, right? So now you have 2, 21, 5, 26. So what we will do, 2, okay, then comes what? 5, then comes 21, and then comes 26. Now what did we do? We have compared all the ones, we have compared all the 2's, and we have compared all the 3's. This is going to be your iteration number 2, right? You understand? Though this is one step, but only after you do the second step, this iteration 2 is complete. Okay, now you have the iteration 2. Now what is the step we should be doing? We have to again divide it into what? D is equal to number of elements divided by 3, right? Number of elements we had was 3 elements, so D is equal to 3 elements divided by 2, right? 3 elements divided by 2, not 3. 3 elements divided by 2. So it has to be 1, which means we have to compare each and every element here, right? So what happens now? You are going to sort the whole thing. Actually, literally speaking, you are going to be sorting the whole thing. So I will compare 9 and 1. It will become like 1, 9. So 2 and 19, it will be 2, 19, right? Then I will be comparing 11 and 5, and it will be 5, 11, right? Then I'll be comparing 27 and 13, so it will be 13 and 27, right? So what you can do instead of this is, I would ask you to do an interchange sort. So since we have studied interchange sort, because you can skip a lot of iterations, you can leave this method because it will take you to more iterations. You have to keep doing it. Okay, instead I would ask you to go for interchange sort now, right? So when your value is going to be D value becomes 1, after that you just perform an interchange sort and things will be sorted out. So what is interchange sort? 9 and 1, it becomes 1, then 9 it becomes, so 9 and 2 now it becomes 2 and 9. So 9 and 19 now it becomes what? 9 and 19 only, there is no change. 19 and 11 now it becomes 11 and then becomes 19. So 19 and 5 now it becomes 5 and then 19, right? And so on. So again 15 and 27, 15, 27. So after you finish the interchange sort, you can see that the list is sorted, right? So that is what we are going to do. So one more tip I will give you: after doing all the iterations, check for the list. Maybe you have done some mistake in between, so that your list, maybe it is not in a sorted order. But make sure to write the sorted order. You know to sort it, right? You know, human sort, you know, right? How do we sort numbers? So just write it in your ascending order so that your answer will be correct. So do that. Don't forget to do that. So if you find interchange sort easier, so I've used interchange sort here. And first you will find the largest, then second largest, third largest, and then you would have sorted the whole list. Okay, but what is the actual method of doing it? So actual step tells you compare all the ones, all the twos, and all the threes. Here you had 1, 2, 3. Okay, here you will be dividing the list only in terms of 1. So 1, 1, 1, 1, everything is a 1, which means all the ones has to be compared and sorted, right? So that is what you should be doing. That is the actual technique, right? So one more doubt I usually get from students here: 3 by 2, you can say it is 1.5. Should we take it as 2 or should we take it as 1? You can do it in both the ways. Okay, if I take it as 2 also, it is fine. There'll be one more step, that's it. If I take it as 1 also, it is fine. You will reach this last stage, right? So both you can try. So if you want, I will also try that. So let us say 3 by 2, 1.5. I'm going to take it as 2. I'm going to round it off to 2. So what happens now? You will group it like this. So you will be grouping it something like this. So we are going to have groups of 2, 2 in a group. Okay. So let us take these numbers. These white ones are all second group. These are all the first group, 1 and 2. Now what is the method tells you? The method tells you that you have to sort all the ones and all sort all the twos. So what is the sorting of all the ones? Let us say 9 is here, then you have 11, okay, then you have, so you have 9 here, then you have 2 here, then you have 11 here, then once we are considering 1, then you have 27, then you have 21, and then you have 16. right? So these are all the ones. What we should do? We should first sort it. So it becomes 2 and then 9, right? So 2 and then 9. 9 and 11, yeah, it stays say the same way. 9 and 27 stays same way, but 27 and 21 doesn't go. So you're going to be 21 and then going to be 27, right? 21 and 27. So 27 and 16, obviously 16 here and 27 here. So we have done it. Just check again, is it sorted? 2, 9, 11, 21, 16? No. So again, what we will do? 16 and 21. So what we have done, compared all the ones successfully. The next step is I have to compare all the twos. So how am I going to do it? So I have 1 here, I have 19 here, so I have 5 here. 5 is obviously smaller, so I'm going to put 5 and then I'm going to have 19, right? So then I have 19 and 13, so I'm going to have 13 here and then I'm going to bring down the 19, right? Now I have 31 and 19, obviously 31 goes here. Then comes 26, but 26 is smaller, 26, 31. So this iteration is over, right? So what we have done with, we have said consider it as 2, so the iteration is not at over. Still there is one more step where you have to say it's equal to 2 divided by 1, which is nothing but equal to 1. So you have to again consider every element. Here what you will do, 2 and 1 you will compare, you will get 1, 2. Then you will compare 1 and 9. Okay, I'm sorry, 2 and 9. 2 and 9 remains the same, no change. So you have to compare 9 and 5. So 5 will go here, 9 will come here, right? 9 and 11, 9 there, 11 there, 9, 11 and 13, 11 and 13, no change. 16 here, 16 and 19, 19 here, 21, 21 here, 21 and 26, 26 here, 26 and 27, 27 here, 27 and 31, 31 here, right? So this seems to be easier. So if you are familiar with interchange sort, you can also finish it with interchange sort divided by 3 divided by 2. You can take it as 1, do an interchange sort and finish. Or else if you wanted to complete the same technique we use, you can consider as 2 and then you're going to say 2 by 1, again consider it 1 as 1. Okay, so just look at our iterations. We had 12 elements. We divided into 6 and 6. Then we divided them into 3 and 3, 3, 3, 3. Then we have divided the 3, 3 into 2, 2. Then 2, 2 we have divided into 1, 1. Right? There is an in-between step which you always used to forget. That is nothing but when you saw compare ones, all the ones has to be compared. So see, make sure that all the ones are sorted. So there should be a sorted list here already. All the whites should be sorted, all the blues should be sorted, all the yellow should be sorted here. So that is what you should make sure. If you are able to catch that, it's very, very easy. This technique is very easy. Okay, so I have taught you in two different ways. So this shell sort can be done in two different using two different techniques. Okay, hope you have understood. The next technique we are going to see is nothing but your radix sort. It is also called as bucket sort. Okay, it's very, very simple. The bucket, why it is called as bucket sort is how many ever digits you have. So if you're going to use decimal number system, so you have 0 to 9 digits, so you will have 10 buckets, 0 to 9, so there will be a total of 10 buckets. So that's why it's called as bucket sort. So again, I'm going to take the given same numbers I'm going to take and we're going to sort it using this bucket sort. So we have two steps here. Since the number of digits is 2, so we will have two iterations only. If the number of digits is here is going to be 3, then we'll be having 3 iterations. Okay, so or else remember like this, 2 digits, you have 2 buckets. Okay, so there are only 2 steps to do, right? Just see, what are we going to consider in the first step? So always we start from the least significant bit, which is the LSB. Whatever it is, say for example, there is a number, say this is the number. So the least significant bit here is 2. Most significant bit here is 4. Okay, so that is what we are going to do now. We are going to start from this 2 and then go 2, 3, 5, 4, like that we are going to keep considering. So 2 is going to be the least significant bit. So this is for an example I told you, right? So here I have 19. Okay, what is the least significant bit? 19's least significant bit is 9. 13 is 3. So this is 0, 5. We will consider it as 0, 5. So it is 5 only. This is going to be 27, 1, 26 and so on. Okay, first thing what we are going to do is we are going to consider the least significant bit. Okay, the least significant bit 19 is 9. So I'm going to put 19 in which bucket? Bucket number 9. Yes. So I'm going to, let us just assume that you have numbers in kind of a block and then you have a bucket. So you're going to take that number and put it in a bucket. So that's what we are going to do. So 19 goes to ninth bucket. 13 goes. 13 has 3. 3 is the least significant bit. So it goes to the bucket number 3. Then you have 5, 0, 5. So it goes to the 5 is the least significant bit. So bucket number 5 is what you have 5. Right. Then you have 27. It goes to least significant bit there is 7, so it goes to bucket number 7. Then you have 1, least significant bit is 1, so it goes to this bucket. 26, it goes to this bucket. 31, 1, so it goes here. So already you have a number there. So what happens here? I have to put a say comma and write. So you're going to say 31 is going to go here, bucket number 1. Done? Yes. And go on. 16, bucket number 6, you already have a 26 there. So I'm going to put comma and write 16. So there are 2 elements in a single bucket, right? 2 is the least significant bit, so it goes to the second bucket. Again 9 is the least significant bit, it goes to the ninth bucket. Already there is a value, so I'm going to put a comma and say 9, right? Then you have 11, it goes to bucket number 1 again. So comma 11. You have 21, again it is going to go to bucket number 1 only because 1 is the least significant bit. Yes. So far what have we done is we have put the numbers based on their least significant bit in these buckets. What is very important is the order in which you're going to consider. Now we will leave this list. We will start from here. So our list is nothing but 1, 31, 11, 21, 2, 13, 5, 26, 16, 27, 19 and 9. This is our list. So we have to now sort it. Okay, now the next step is you have to go one bit from your left side. I'm sorry, from your right hand side, you have to go to your left hand side. So we only have 2 bits. So first LSB is over. Now we will go to MSB, most significant bit. Right. So let us consider the same thing. I will just move this here. Right. So now the same thing is what is going to happen. But we are not going to see this list. Instead, we are going to see from here. Right. Yes. First thing, we are going to see the most significant bit. 1. What is the most significant bit of 1 here? Can I say 0? Yes. So I can say 0. I'm going to put 1 in the, this most significant bit is 0. So I'm going to put it there. 31, it is going to go to the bucket number 3. 31. 11. So most significant bit is also 1 here. So it is going to go to number 1. Bucket number 1. 21. The most significant bit is 2. So it is going to go here. Right. Next is 2. So we are going to consider that as what? 0, 2. So it is going to go to the 0 bucket. 0 is the most significant bit. So it's going to be 0, 2 is what it's going to be considered as. Right. Then comes 13. So 13's most significant bit is 1 again. So it is going to go here. 13. Then you have 5. 5 again it's going to be most significant bit is 0. So it goes here. Then you have 26. So 26 most significant bit is 2. So it has to go 26. 16 most significant bit is 1. So it will go here. 27 most significant bit is 2. It will go here. Yes. Then comes your 19. 19 most significant bit is 1. So I'm going to put it here. 9 most significant is 0. Most significant bit is 0. So I'm going to put it here. Right. So what is very important here is the order in which you have written already. Okay, don't go to the same order, you will be confused. This order is what you are supposed to take. Using that order, using MSB, we are going to again put them in buckets. Then you have the sorted list here. I'm going to put the sorted list, just the same list here. Whatever we have here, the same order. So it will be 1, 2, 5. You have to write the sorted order also. Only then your problem is correct. Right. So this is going to be your sorted list. Easy. Yes. So only 2 steps here. One is you'll take the least significant bit, put them into appropriate buckets, take the most significant bit, put them in the appropriate bucket, and you're done. That is going to be your bucket sort or radix sort. So radix sort is a very, very easy sorting technique. So we'll move on to the next sorting technique now. Your next sorting technique is radix exchange sort. Radix exchange sort. So the difference between radix sort and radix exchange sort, there is no similarity actually. It is completely different. So what we will do here is the given number will be converted into a binary number. Say for example, the given decimal number here is 19. It has to be converted into zeros and ones or to binary. So I have used a function here in Excel, decimal to binary. So I have taken this B4 as the cell. So I have converted all the given number into binary. That is the first step. Okay, so first whatever given list is given to you, you have to first convert them into binary, right? Yes, once it is converted into binary, then this is what we are going to do. Just listen, we will take from the most significant bit. So unlike the previous method, it's completely different. We are not going to go from the right to left, we are going to go from left side to right side. So what we have to do, take one at a time. So let us say which is the column we are going to take. We are going to take the first column and it is going to keep changing. So I'm going to take the first column now, right? So let me show you here. Okay, this is the column I'm going to use, right? And we are going to keep shifting. So let us see how that is happening. Okay, so let me start now. I'm going to take the first one. Just look at only, don't get confused, look at only the first column. Okay, the first column can either be 0 or it can be 1 because it is a binary number. It cannot be any other number. Just see that whether it is 0 or 1. If it is 1, write it below the line. If it is 0, write it above the line. That's all is the technique, right? So I have first number, I have the first digit as 1. So that goes where? Below the line. Zeros will go above the line, ones will come below the line. So I'm going to write the same number here. The only thing is we should be very careful in writing the number. We may miss out. So the order will change now. The list may change. That's why be very careful. So its first is starts with 1, so it comes down. Second list starts with 0, so it goes above the line. So it could be anywhere. So whichever place of the line you're going to write, it is fine. So there's no like first row, second row and all. Second number I have taken, it starts with 0, so I'm just putting it here. So it's going to be 0 1 1 0 1, right? Done. Okay, so next number we are going to just go on like this. You understand? So there can be more numbers which is starting with 0, more numbers can start with 1. Again, it depends on the list we have. So there it is not equal. Say for example, there are 12 numbers, it will not always not be 6 and 6. Okay, or it will never be 6 and 6. Always it is going to change only. So there's just a line just above the line and below the line is what we are going to look into. Right. So we are done with two numbers. Take the third number. So it is starting with 0. So it comes here above the list. So I'm going to put it 0 0 1 0 1. Yes, next number starts with 1, so I'm going to put it here 1 1 0 1 1. This number starts with 0, it goes here 0 0 0 0 1. Yes, so we have done this. This is the number again starting with 1, so it goes here 1 1 0 1 0. Then we have 1 1 1 1 1. This is also starting with 1, so 1 0 0 0 0. This number is going to start with what? 0, so it goes here 0 0 0 1 0. This again starts with 0. So 0 0 0 1 0 is done. So 0 1 0 0 1. This number again starts with a 0. So I'm going to put it 0 1 0 1 1. This number is going to start with 1. I'm going to put it 1 0 1 0 1. So I just now told you it will not be equal, but in this case it is equal, and it depends. Again, the list is what is going to decide, right? So the font also, let me increase it. Right, so this is the list I have. So what have I done? I have successfully I'm sorting it. So we're going towards the sorted list, but this we are in half the way only, right? So what we did, we took the first column, zeros, all the numbers with zeros in the beginning goes here, all the numbers with ones in the beginning goes here. That's it. Now the same thing we are going to keep doing it, but we are going to again take this as one list. This is a separate list now, right? We will finish this list and then come back to this list. Okay, so that's what we are going to do. Now this we are going to take as an independent list. The only thing that is we should remember is that, okay, we are going to come here. I'll keep it here. Now we are going to compare this, take the second column, right? The second number is what we are going to take. I'll just move it here so that you understand, right? So paper and pen did not work for me, so I thought of using Excel sheets. Okay, so there is anything you please, you have to adjust, right? So here again, what are we going to do? We are going to divide ones and zeros. So what I will do now, I will just have a line drawn here. So just I'm going to put zeros on one side and ones on the other side. So which list is going to be bigger, we don't know, so accordingly we will adjust, right? So here, first list. So here now we are considering the second column, okay, or the second digit. This is starting with 1, 1 is below, so this number is going to go below 0, 1, 1, 0, 1. This number is 0, it is 0, so above the line. So let me say, so this is the line, above the line, second number 0, 0, 1, 0, 1. This is again 0, so 0, 0, 0, 1. Yes, this is done. Now we are going to take this number again, this is going to be 0 only, so 0, 0, 1, 0. Yes, this number is going to be second digit is 1, so it comes here 0, 1, 0, 0, 1. Same way here, again it is 1, so it's going to be below the line, so 0, 1, 0, 1, 1. Yes, so we have the list here. What did we do? We compared, consider the second ones, all the ones, this one, this one, this one came down, all the zeros, these three, the zeros came up. So what we have done is, consider the second digit, zeros, all the zeros on top, all the ones in the bottom. Same thing has to be done to this list also. Now, same thing has to be done to this list also. So I have to draw a line in between them. So let me say I'm going to just draw this line. It can be, doesn't have to be in the center, it can be anywhere. Right. So if it is done in a white sheet, it is easy for me to insert. So let us see what can be done now here. Okay, zeros. How many zeros you have? You, thank God you have three numbers here. Three zeros. 0, 0, 0. All that on top, 1, 1, 1 on the bottom. Right? So the first number 1, 0, 0, 1, 1. Second number is this. Okay, because that is also 0, 1, 0, 0, 0, 0. The third number is this. So 1, 0, 1, 0, 1. Now, so all the ones. This first one is here 1, 1, 0, 1, 1. The second one is here, this one 1, 1, 0, 1, 0. Third one is here, it's going to be 1, 1, 1, 1, 1. Right, so we are done with the second step. So we have to just keep doing the same thing. So what I will do here, I will again draw a line, all the ones on top. So this will be considered as one list, second list, third list, fourth list. Separately you have to divide them into zeros and ones. Okay, so let us do that here. So let us see what is going to happen. So I'm going to just put, let me leave one line here just to avoid confusion. I'm going to start here. So what we should do now, then consider the third digit. So this is the third digit here. Right, so that is one thing I should do. Second thing I should do is divide it into two columns. So let us say divide into two. So okay, you can virtually imagine that it is divided into two. So top zeros will go, ones will come in the bottom. So that is the idea here, right? So now we are going to consider the third column or the third digit, right? Slightly here, third digit. So what happens? This is going to be one list. This is going to be one list. This three alone we have to look into now. Just look at these three numbers. Okay. So what is all zero? Put here. So zero is here. 0, 0, 0, 0, 1. Okay, this is also 0. This one, can you see the third digit 0? So we are going to put 0, 0, 0, 1, 0. Done. This is the one part of it. So 0, 0, 1, 0, 1. So what have we done? We have just taken this small list and then divided that into zeros and ones. So let me draw the line now, so you will know where it is, where the line actually comes. You understand? This is 0 part, this is 1 part. Okay, and this line obviously is going to be there throughout. Let me say this line is also going to be there throughout, no doubt about it. Similarly here, right? Yes, so one more line, zeros and ones. Same thing again here. So you have only these three numbers. Just see 0, 0 and this is 1. So I'm going to first write 0 number 0, 1, 0, 0, 1. Then the second 0 digit is 0, 1, 0, 1, 1, which is these two. Can you see third digit is 0? This is 1, so this goes below 0, 1, 1, 0, 1. So what I will do again, put a division here. So above the lines I have the zeros, below the lines I have the ones, which is the digit we are considering, the third digit. We are considering the third digit. Yes, it's done there. Again we will go here, third digit 0, 0 is here, 1 is here, so it is going to be the same order, 1, 0, 0, 1, 1. Okay, 1, 0, 0, 0, 0, and then this is 1, 1, 0, 1, 0, 1. So again I have to divide it into 0 and 1. Okay, we are into the third column. Third digit should be zeros, third digit should be 1 here. Same thing here. So it's the same order. You can see two zeros and one one, 1 1 0 1 1, 1 1 0 1 0, 1 1 1 1 1. Right, so these are the, this is how you divide them. So this iteration is over. So we had the given number converted into binary. So first iteration we did, wherein we considered only the first what column. Okay, this was the first column considered. The list was divided into two. All the zeros above, all the ones below. This is the second iteration, right? Second column we considered. This is the third iteration where we have considered the third column. This is also done. So now how many columns are there? There are actually 5 columns. So we have to do 5 iterations. So this is going to be next iteration. Let me tell you, we will go to the fourth digit. Okay. And then here we go. Right. So here, wherever you have a line, that is one list. Remember that. Okay. This just is one list. This one alone is one list. These two are one list. 1, 2, 1, like that. This is going to be how we are going to divide it. So here what did we do? Yeah, here also one line is missing previously. Okay, so third digit was there previously, so these two are zeros and that is 1. The line is missing. Now wherever there is a line, it is a separate list. Okay, just it's going to be easy for you now, right? So what are we going to do here? Fourth one, 0 will go on top, 1 will come below. That's all it is. 0 0 0 0 1, 1 will come down, so 0 0 0 1 0. Yes, yes. Now this is a separate list, so we don't have to do anything. It just straight away goes into the list. That's it. So it is 0 0 0 1 0 1. So it is 0, but it is not divided into 2 because there is no other number there to go. So what about these two? We will see, one is 0 and one is 1. So it's going to be like same like this. 0 will go above, 1 will come below because it is the fourth list. Same thing we are going to do here. 0 1 0 0 1. Okay, and this is 1, fourth digit 1 is here. 0 1 0 1 1. Okay, it is actually easy. Once you do it, you have to, all the methods you have to do it once only, then you will find it very easy actually. Without doing it is going to be very difficult. That day you will not remember also what is happening. Okay, so make sure you do it, work it out yourself. Right, so here as I told you, this list has no competition. So 0 1 1 0 1, that's it. It is going to be a zero list, but never mind, we're not going to draw any line there because there is only one number. Here you have two digits, so you have 1 and 0. So here you have to first write 0 and then write 1. Okay, 0 I have written, this is the 1 I am writing. Okay, so yes, so zeros on top, 1 below. So this again no competition, 1 0 1 0 1. It is 0 number 0, but you don't have to divide it. Here you have both 1, so you don't have to divide it. So you can just write the same thing, 0 1 1 and then 1 1 0 1 0, and then you have what, 1 1 1 1 1, right? So we have done with the fourth iteration. This is what you get after the fourth iteration. One more iteration is remaining. Shall we do that? Yes, so we are going to the next iteration. So before that, these lines wherever left out I will draw. Yes, okay. Yes, wherever there is a line, which means it is one list, it's considered as a separate list. Now I'm going to move it to the fifth digit. Now, so all these are, you can see that all these are the same. Okay, there is only one number, so there is no segregation required. So we have to just write it. So it is one number, but no top and bottom because this is a separate list and it has only one digit. So you'll just go with that 00001. Then you're going to go with single list 00010. Then you're going to go with 00101. No competition 01001. 011. Here also single line only is there, single list 011, no division is required. So here also no division is required. Here also no division is required. Yes, here also. Here there are two things, so you have to divide them. First 0 will come on top, so 11010. Here 11011. Then comes 11111. Right? So this is going to be your sorted list. So what we have done, this iteration, we have actually considered the last column alone. Okay, and it is done. So 5 iterations were there. This is the final list you get after all the 5 iterations. In this list, particular list, all will be separate lists. So that is what has happened. We have considered everything as separate lists. Right? So everything here is going to be a separate list. I am not drawing that line now. Right. So how will you know what is the result now? So result will be again converted into the decimal number, that is the result. Yes, here I am using a function again, binary to decimal conversion. So I have converted binary to decimal. This is the first number. If I do the same thing for the whole list, you will get the sorted order. Fingers crossed. Hope you didn't do any mistake in between. Right. So 1, 2, 5, 9, 11, 13, 16, 19, 21, 26, 27, 31. Fine. So this is going to be your sorted list. This method is called as radix exchange sort. You're going to take a given number, convert it into binary. So in exam, if this question is asked as a theory question, don't consider 5 digits. You will have a long procedure. Consider only 3 digits. Okay. So depending on the time, you can take 3 or 4 digits so that you will have only 3 or 4 iterations depending on the number of digits. And you don't have to have 12 numbers. 5 number is enough. So I would say 5 number is enough. Actually, 5 number is enough for all the techniques to be explained. Okay. Until and unless a list is given to you, you can choose your own list. So keep it simple. Right? As I told you, make sure that the last answer, whichever you're giving, is sorted. Okay. If it is not sorted, make sure you write a sorted order there. Okay. Yes, maybe there is a small mistake which you have done. Okay, that is what, so you should consider. So at least make sure your answer is correct. In between steps marks you will lose, but at least make sure you get the right answer. Yes, so this is going to be your radix exchange sort. The next sorting technique, the last one, is called as address calculation sort. Okay, this is again a sorting technique. Just see, this is a given list. Okay, so what the sorting technique says is, first you have to calculate the address. So what do you mean by address is, you have to take the biggest number here, whatever is the largest number, divided by the number of values you have. Okay, for example, here I have 12 numbers. In this particular list I have 12 numbers to be sorted, so I will take the largest number, which is nothing but 31. I divided by 12, I will find an address. This address is called as the found address for your address calculation sort. Highest number divided by the number of numbers, right? Yeah, 31 by 12 here, 2.58, I can say, round it off to 3, right? Keeping this address, I will be calculating an address for all the numbers. Okay, so where I wanted to keep all this number is what I'm going to find out now. How I'm going to find out? I'm going to do something like 19 divided by 3. Okay, so 19 divided by 3, 13 divided by 4, and we are going to round it off. Okay, whether it is going to be upper bound or lower bound, don't worry, whichever bound you use, you will have a different method, but anyways you will sort it in the end. There won't be any confusion, don't worry. Right, so 19 by 6. Okay, so I'm sorry, 19 by 3. So 19 by 3, 6 3s are 18, so I've taken 6. So I've taken the lower bound here. I'm going to have 6 as the address, calculated address. For 13, the address we have here is 3, so divide all these numbers by 3. That's it. Okay, 13 divided by 3, 5 divided by 3, 27 divided by 3, 1 divided by 3, and so on. Right? So this is what I get. This is the address I get. Okay, so with this address, what will I do? I will show you what we have to do. Okay, so I've hidden it so that it is not confusing for you. Till this, do you understand? First, we calculated an address, highest number divided by the number of elements. Okay, that address was 2.5 something. Let us consider it as 3, and every number has to be divided by 3. Lower bound or upper bound, anything is fine. Okay, yes. Now, these are the, it's like your bucket sort only. So these are the address locations. So I have address location 0 to how many ever numbers are there. I have 12 numbers, so 0 to 11 all the address locations. So this is the address I have. So where will 19 go? It will go to address location 6. Okay, it's going to go to address location 6. So let us see here. 19 has to be placed in address location 6. Okay, similarly 13 has to go to address location 4. 5 has to go to address location 2. Right, 5 has to go to address location 2. 27 will go to address location 9. 1 will go to address location 0. 26 will go to address location 9 again. Okay, here see, in address location 9, okay, till this we didn't have an issue. Till 1 we didn't have an issue. We had empty spaces where we can store these numbers. 26 again has to be stored in the address location 9. In one location only one number can be stored. Okay, unlike the bucket sort, here only one number can be stored. So again, already there is 27 there, but you wanted to store 26. Now comparison will happen. If whichever is the smallest number, that will hold the position, the other one will be pushed down. Okay, you are literally pushing it down. So how you should actually write it is, in your notebook when you're writing it, you have to write it, put an arrow mark and show that this number is pushed down. Yes, so what happens now? 26 comes here to position number 9 and just push it down. That's it. Right. 26 done. 31 is number 10. Again, we just now pushed 27 to this location. Now you have 31 also coming to the same location, which is not possible. So we are going to say 27 is already there, then put 31 in the next address location. Here also what we have done, we've actually pushed the number 31. Right, 16 is number location 5. 5 you have 16. Okay, so 5 you're going to put in location number, I'm sorry, 16 you're going to put in location number 5. It was empty, so no problem, I have put it in location number 5, no problem. Okay, it was empty already. 2 in location number 1, so here also it was empty, so far we have not used 1 at all, so 2 is going to be stored in location 1. Done. 9 has to be stored in location 3, so 3 also we have not used, 3 was empty, so I have stored 9 there without any issues. 11 has to go into location number 4, so location number 4 already has 13, so 11 has to go into location number 4. So what I will do, I will do the pushing thing, I will push 13 down and then store 11 there. When I push 13 down, I find that 16 is here, I am pushing that down, then I found 19 was there, I am pushing that down also. Yes, yes. Then 21 is there, so where I will put the 21, I have to put in location 7. 7 already there is 19, so I'm just putting one location. Then I will compare 19 and 21. 19 is smaller, so 19 comes first, then I'm going to push 21 down to the 8th location. If you see now, you have these numbers. So you have numbers from 1 to 0 to 3. Here we had some pushing down, so 4 to 8 is this list. Here also we had some pushing down, so 9 to 11 is this list. So I'm going to write everything together now. If you see this, this is going to be a sort, this is going to be the sorted order for us. Yes, we got our sorted order. Can you see? Yes, this is called as address calculation sort. So let me repeat the address calculation sort. We first calculated something called as an address, highest number divided by the number of elements. Using that address, we divided that address with all these elements. Okay, so every element divided by the address, you got these addresses, calculated addresses. These are called as. And based on the calculated addresses, so we are going to have address locations here. So I can remember this like a pointer. You have memory locations, you're going to put these numbers in that particular address location, whichever is calculated here. Whenever you find a number already existing, you do a comparison. Whichever is a smaller number comes first and the other number is pushed down, and so on. So you get the sorted list. So far we have discussed all the sorting techniques. First was the interchange sort. It was very easy sort. You compare first position and the second position, and then you keep doing that until you get the sorted order. So usually what happens, if you have 12 numbers, then you will need 12 iterations to finish it, to sort it. Next comes shell sort, though it is a little confusing. Once you do it on your own, it is going to be very easy and simple. What we did, we took the list divided by 2. Okay, then you made it into 6 and 6. So you compared ones and ones, twos and twos, threes and threes. Again, you're going to divide this list by 2 again, divided by 2. So 6 by 2 is 3. So 3, 3, 3, you have 4 lists you have actually. So you're going to compare all the ones of these 4 lists, all the twos of the 4 list, and all the threes of the 4 list. Right, and then you make sure after comparing it you write it here, and then make sure that all the whites here, for example all the ones here, are they in sorted order. If they're not in sorted order, please sort it. Okay, then all the twos you will compare and see whether they're all in sorted order. If they're not, sorted threes and so on. Then you have this list, you have divided again divided by 2. So I'm going to consider the upper bound, I'm going to say it is going to be 2, and I'm going to divide the list into twos, 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 2 I divided. Then compare all the ones and compare all the twos. You compared all the ones and then compare all the twos, you get the list here. Right, all the ones should be sorted, all the twos should be sorted. After doing that also, this is the list you have with you. This is the list you have with you. This is it sorted? No, not it. Until you get D is equal to 1, only that list will be the sorted list. Okay, so here again you divided that, and you're going to be 2 divided by 2. You said 2 divided by 2, and that is going to be nothing but 1. Okay, 2 divided by 2 is 1. So you have to consider each and everything. So all the ones. So you consider all the 1 and 1, you compare 1 and 1, you compare 1 and 1, like that you compare every element, and this will be your sorted list. You understand? This is shell sort. Bucket sort was very simple. We had buckets. You start with LSB, least significant bit, and move to the most significant bit. So you had buckets 0 to 9, depending on the number system you have. Okay. So depending on the number system, this is decimal number system. So you only will have numbers from 0 to 9. Right. Then you had the most significant bucket. When you did these two steps, what you had already was your sorted order 1, 2, 5, 9, 11, 13. This is your sorted. You take it down and write it down. Right, radix exchange sort, it is little complicated you may feel, but when you do it, it is very interesting, but take less number of digits, don't go for these many what do you say, digits. Okay, so 3 digits will do for your exam. This I thought I could have used 3, but when you use 3 the understanding is not that better. So if I have more digits, then you understand the method properly. Okay, any doubts you can always get back, you can comment WhatsApp. Yes, and I will get back to you. Right, this is radix exchange sort. We had given number converted into binary. So that binary number again I have written as 5 digit, because only if it is 5 digits I'll be able to proceed with the steps. So what I did, this was my binary number. That number I'm going to write it in terms in a form of 5 digits. So if it is 101, I'm going to write it as 00101. So it is 1, I'm going to write it as 00001. So I make sure that there are uniformly 5 digits with all the numbers preceding zeros, if at all it is not. Right, then I took the first column, divided them into zeros separately, one separately, then took the second column, divided them into zeros and ones, and so on. So 5 iterations I got. If I could do the 5th iteration, what I have is the what? Sorted list, but the sorted list here will be in binary. I should convert it into decimal, so I will get the actual list. Understand? This is going to be known as the radix exchange sort. The last one is the address calculation sort. So this is what we saw. So we said we took the numbers, we calculated the address and put them in that particular address location, and then you get the sorted order. Okay, so when you're studying it in exam point of view, first remember the techniques. Take your own example, practice with your own example. Just take 5 elements enough and try to sort it in various techniques. So mostly you'll be asked to sort your own number, so which means it will be asked in theory, so you have to just explain. Okay, it is a definite one question definitely from this topic. So if you know the method, you can write your own steps, one example you give, you're done. Okay, definitely one or even more than one question will be asked, can be asked in this particular topic. Yes, hope you have understood sorting techniques. So with this, the second unit is covered. So in second unit, what is that you should study in assembler? So you have studied the databases. You also can study data structures. It is the same, one and the same. What are the data structures used in your assembler, pass 1 and pass 2? So that is one thing you can study. So you can study what are the databases used, and also, as I told you, flowchart. Don't forget to study the flowchart. So these are the important questions in unit 2. So next class we will move on to macros. So macros I'm choosing because it is an easy, very easy topic. So you don't have to leave it for people who are just worried about their clearing the exam and getting at least 60% of the marks or so. It is enough if you study these 3 units thoroughly. Okay, so that is why we are going to start with macros and do some important topics in macros. Okay, thank you.